Hello, everyone, and welcome to day 2 of expected value. So today we're going to do more of the application of expected value and how to make some decisions based off of it. Okay, there's many jobs that deal with this. Okay, one I can think of off the top of my head is an actuary, where they have to take and figure out which decision makes the most money, okay, especially when dealing with insurance purposes. So we're going to look at a lot of insurance problems today. First one, our warm-up. An insurance company charges an annual premium of $480 for car insurance. There's a 10% chance that you'll get into an accident and need a $500 repair. How much money can the insurance company expect to make in profit per year? So think about how you would do this. The idea of expected value, pause the video, take your time. When you're ready, I'll show the answer. Okay, so we're paying the car insurance company $480. Now, 10% of the time, we're going to have to pay $500, and 90% of the time, we're going to have to pay nothing. So we can look at this as an expected value problem. Okay, if 10% of the time I'm going to have to pay $500, okay, I can do 500 times 10%, and on average, I'm going to pay $50. Now, the car company's either going to have to pay 500 or nothing, but average per customer is $50. So they can take the 480, they subtract the $50 per person, and they make $430 profit. Okay, like I said, the company collects $480, has to pay an average of $50 per repairs annually per person. So over the course of 10 people, they should have to pay $500, but over 10 people, they make a whole lot more. So $430 per person, and if they'd ask you how much could they make for 10 people, we can multiply and we can take that information. So that's how insurance companies kind of determine what their premium is. They figure the average costs or the average cost per customer, and then they choose a cost to you that's higher than that so that they can make enough money from you. So once again, expected value is the average outcome. So in the last problem, we could have looked at it differently, and we could have said that they make $430 from 90% of their customers, or never mind, I take that back. Okay, they don't make $430. They make $480 from 90% of their customers, because 90% of the customers they don't have problems with. And then they're actually going to lose money from 10% of their customers because the cost to fix is more. So this is how we could have used the expected value in that problem. And we use it to make decisions. Sometimes I want to know what's the best option, how to make the most profit. What profit am I going to make? An expected value takes probability and does all of that for us in a theoretical sense. Here's another example. Car owner is considering 3 options. We have option A and B and C. In each one, you pay a premium, and then you have a deductible. Now, the deductible is the additional cost that you have to pay if you get in an accident for the repairs. So for example, option B. I pay $447 at the beginning of the year, and then if I get into a car accident, I have to pay an extra $200. I pay the first $200 for the repairs, and then the insurance company takes care of the rest. So a car owner is considering these 3 options. Statistics show there's a 10% chance of needing a repair, average cost of $500. Which option has the least expected total cost to the owner? Okay, and then B, find the insurance company's expected income for each option. Which one is the best for the company? So which one's the best for you as the car owner, and which one's the best for you as the owner of the company? Pause the video, take a few minutes, run all the expected values, all the situations, figure out which option you would want if you were buying car insurance, and figure out which option you'd want if you were owning the company. Okay, so I'm going to show you a step or show you how to do option A. And then if you need to repause the video because you've calculated expected value wrong, do that. Make sure you understand how to calculate this expected value. So option A, okay, it's going to cost you $480. Okay, $480, 90%, 100% of the time. Okay, 10% of the time we have to pay an additional deductible, but since the deductible is zero, it's $480. Pause the video if you need to recalculate. If not, here we go. So option B, we have to pay $447, and then 10% of the time we have to pay an additional $200. Okay, we could look at this slightly different and say, okay, we can pay $447 90% of the time, and we can pay $647 10% of the time, and that would still get you an average of $467. And option C, same thing, we calculate the expected value. So which one has the least expected cost for you? Option C. Okay, if there's a 10% chance. Now, if the percent chance changes, then we got to recalculate expected values. But this is how people who understand finance calculate. They say, well, this should happen about 10% of the time, so I want to pay on average $452. Now, I'm only paying $402 if I don't get into an accident, but if I do get into an accident, I'm paying $902. So C is also the riskiest, but it has the lowest expected value over the course of all of the years. Now, option B, we do the same idea, except we, as the car company, we're collecting $480 and we're subtracting the cost of the accident. So in the parentheses here, I have the accident cost minus what the owner of the car pays. So $500 that I'd have to pay to repair the car minus $0 deductible. And the same thing's true for all the others. Okay, I make $447 profit, and 10% of the time I'm going to have to pay $300 for the repairs because the owner of the car pays $200. Now I want profit if I'm the owner, so I want option A. So I'm hoping that the person chooses option A. They give me $480 a year, and if they don't get into an accident, I get $480. And if they do get into an accident, I'm going to be stuck paying for the repairs, but I'll still make profit in the long term. So this is how we use expected value to analyze different options and see which one's the best choice. And this one's the best choice theoretically. Obviously, if you always get in an accident, you probably want the top one, so you don't have to pay extra when you get into an accident. And that's pretty important as a high school student. If you know you get in more accidents, you may want to pay more money up front to not have to pay money when you do get into an accident. Now let's do some more exploring. So we can use binomial probabilities and expected values together. So according to the weather app on Talisha's smartphone, there's a 40% chance of rain for each of the 5 days. How many rainy days should she expect? So first off, I want you to find the probability of it raining exactly 0 and exactly 1, and do a lot of binomial probability to find the probabilities of each amount of days raining. Then I want you to do the expected value. So pause the video, take your time. This problem is a long one. Okay, so we are reviewing expected value, but we got to look at binomial probability first. So probability of it raining 0 days is 5 choose 0 times the probability of it raining 0 times the probability of it not raining to the 5th power, which is 5 times. And we do that, and pause the video if you need to calculate all the others. Okay, lots of calculations here. There's the rest of them. Probability of raining 0, exactly 1, 2, 3, 4, and 5. And now we can use expected value. Okay, we know the probability of the event times the event, which is 0. Probability of 1 times 1 day of rain. So 1 day of rain, it's going to rain about 25 or 26% of the time, it's going to rain 1 day. And 34% of the time, it's going to rain 2 days. And 3 days, 4 days, and 5 days. And we can calculate that, and we get about 2. Now, as you were doing this problem, you might have noticed, hey, there might be a shortcut here. Okay, is there an easy way to do it? Well, I know that 40% of 5 is 2. Okay, we can expect it to rain 2 times. And some of you may have said, well, can I just say, well, it's going to rain 40% of the 5 times? And actually, you can. So expected value for binomial distributions, and this only works for binomial distributions. Okay, you take the n, which is the number of trials, and you multiply it by the probability of success. And we get 2. Now, once again, only works for binomial trials, binomial distributions, binomial experiments. So where we have a success and a failure, we know how many trials. Do not try to use this expected value formula for everything. A lot of times it doesn't work. Now here's your example. Carnival game has 3 orange lights, 1 green light. They flash rapidly, you push a button, the game stops, leaving 1 light on. If the light's green, you're a winner. If the light's orange, you don't win as much. You actually lose. So complete the table. Then figure out the number of prizes that a player can expect to win if the game is played 4 times. So you're going to fill out this table. You're going to take and use our expected value. You're going to do it well. It's going to take you some time, so pause the video, try it out, see what you get. Okay, so here is my table. Probability that it's going to rain. And I left them as fractions. You can convert them to decimals. If your calculator gives you decimals, round to 4 or 5 decimals and use that. Okay, don't just round to 1 or 2 decimals, you'll create error. So 0, which is the event, winning 0 times the probability of 0 plus 1 times the probability of winning once plus 2 all the way. And I get my expected value equals 1. Now, once again, you may be saying, well, you just told us that we can use, if it's binomial experiment, which this is, we take the number of trials and multiply by the probability, and you could have done that as well. So sometimes we need to know our options to figure out, is there a more efficient way? Both ways get us to the correct answer. But since this is a binomial experiment where I have a 1 in 4 chance of winning, I have a 25% chance of winning on each trial. Okay, 4 trials total, 25% chance per. I can get an expected value. I win once. So expected value, the average outcome that will occur over many, 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 many trials. It's a theoretical expected outcome. A lot of times it's a decimal that we can't actually achieve. For example, the car problem where I expect to make a profit, but I don't make that profit per person. Okay, we saw that the formula, we take the event and multiply by the probability of event, and then we add up all the events times the probability of those events, and we get a number which says I should expect on average this to happen. And then for binomial experiment only, we take the number of trials and we multiply by the probability of success. And that only works if it's binomial. So don't let me see you just trying to use that formula all the time. Okay, it's a simpler formula, but it only works in very specific situations. And that's what expected value is. Useful in making decisions and figuring out average outcomes so that companies can understand profit or how often something should happen.